Well, hello again, friends. Miss Achille here with another test help video. This test video is for the Unit 2 Part 1 test. This test is found on USA Test Prep. The due date for this test is Friday, March 12th, 2021. So let's quickly go over a few of the things that you need before you start your test. Item number 1, pencil and scratch paper. It's a must for doing these calculations. Item number 2, your 8th grade math star formula chart. If you do not have one handy, you can easily hop out to the internet, do a quick internet search, and get a fresh copy. Last but not least, and so critically important for this test, you've got to have a calculator. Your graphing calculator is going to be your best option, and I'll show you why in just a minute, but any calculator will do. All right, quick zoom in on your star formula chart. What are we looking at? We're looking at two sections, surface area and volume. We have been referencing this part of your formula chart for the past couple of weeks. We are focusing on surface area of a prism and of a cylinder. And you see you've got your two different versions. You've got lateral surface area and total surface area. Don't forget, when you see that capital P, that means perimeter of one of the bases. You'll see that a lot when we're doing our surface area problems. And then you need your volume formulas for a prism, for a cylinder, for a cone, for a sphere, all of these that we've been using the past couple weeks in class. And don't forget on this one, when you see that capital B, it means the area of one base. All right, that being said, let's dig right into the test. Start with number 1. There is no picture. So if you're in my class, you know Deadpool doesn't like problems that don't have pictures. Deadpool is very angry, but we're not angry. We can deal with this. Let's check out the problem. So we have a cylindrical shaped silo. So if you've never seen a silo, these are those things like out on a farm, those big, tall, cylindrical, they almost look like towers, and they've sometimes got like a dome on top. They hold things that farmers might grow, like wheat, like grains, like cornmeal, like anything that might be grown on a farm that they need to store in a big old container somewhere. That's a silo. So we've got a cylindrical shaped silo. It has a diameter of 18 feet and a height of 4 feet. Okay. So how much water can the silo hold in terms of pi? All right. So when you're talking about how much can go inside of something, this is a volume problem. So we need volume of a cylinder. Well, I went ahead and got the formula for us from our formula chart. The volume of a cylinder is big B. Remember, that's the area of one of the bases times the height. All right, we got this. Now, they did something tricky with us. I'm going to write down the Miss Achille version of this formula because it's hard for me to remember. Well, big B, oh gosh, the base of a cylinder is a circle. So that means I need to know how to find the area of a circle. Oh, wow. So for me, like I've been teaching in class, I immediately go in and I rewrite these formulas with the version that works better for me. So volume of a cylinder, I'm going to write out what big B is. Okay, volume of a cylinder is pi times the radius squared times the height, right? Because we've got our big B, which is the area of one of the bases, pi r squared, times the height. So like when you get to the STAR test, you show up at the STAR test and they hand you a fresh, clean copy of that STAR reference sheet, it might be in your best interest to quickly grab your pencil and write down the Achille version of these formulas. If this is easier for you to remember than to try to keep it in your head. Oh, what does big B stand for with a cylinder? I don't know. Write it down. It'll take the pressure off. Okay, so now we need the radius. Let's just see what we need. We need the radius, we need the height, and it tells us to leave it in terms of pi. We can tell by our answer choices, look, they all have the pi symbol in them. That takes a little pressure off too. I don't have to multiply by 3.14 or go use the pi button on my graphing calculator. I really just need to do this part and then stick the pi symbol to it. All right, so what's the radius? Yikes, they gave us the diameter. The diameter is all the way across the bottom of that cylinder. I only need the radius. I only need half of that. So for my formula, I need to take half of 18, which is 9. Okay, so let's just plug in what we know. I gotta get back my purple pencil. Okay, we're going to plug in what we know. So pi, we're leaving it alone, times the radius squared. The radius is 9, so times 9 squared times the height, which is 4. Right? So let's simplify that even further because we know what 9 squared is. So pi times 81 times 4. So here is the point where you need your calculator because this is where I'm going to leave you. So you need your calculator. In fact, I'm just going to pull over my graphing calculator. Watch this. Da, 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 da. And you just need to put in your calculator 81 times 4. And when you get that number and you stick the pi symbol to it, you will easily be able to identify the match here in your multiple choice. Okay, let's look at number 2. I'm not going to give you the answers on this, but I am going to lead you right to the goal line so you can score that touchdown. All right, we do have a picture for this one. Find the exact volume of the cylinder. And we can tell this is a cylinder problem because, I mean, look, there's a picture. So I got the formula from the formula chart, volume of a cylinder, big B times H. But again, I need to write the Achilles version because I need to see the individual pieces. So volume of a cylinder, just like the previous problem, pi times the radius squared times the height, right? I break it into individual bites so I could take little bites. Now, exact volume, it doesn't tell me to use 3.14 for pi. It doesn't tell me to do it in terms of pi. So I need to look at the answer choices to figure out, hey, do I need to put in 3.14 or go use my pi button on my calculator? Or can I just leave the pi symbol on there? The answer choices tell you what to do. All these answer choices have pi in them. So once again, we just need to figure out this part of the problem and then stick the pi symbol to it. So let's get to work. All right. The radius is, they did it again. They gave us the entire diameter, which is fine, right? It's fine. It's just one more way they're trying to trick you. We only need half of that. We know each half of this is worth 5, right? If the whole thing is 10, each of the radii is 5. So that's no big deal. So I'm going to get my purple pencil back. So we're just going to rewrite every step of the way. Pi times the radius squared. Okay, the radius is 5. So times 5 squared times the height, which is 9. Okay, let's rewrite it another step because we know what 5 squared is. Pi times 25 times 9. Okay, and once again, this is where I'm going to leave you. You need your calculator. If you can punch in 25 times 9 and get that amount and stick the pi symbol to it, you will easily identify the correct answer here from your list of options. All right, let's look at number 3. Ooh, a new shape, a cone. What is the volume of the cone to the nearest cubic meter? Aha, use 3.14. So they're telling you how to answer it. They want a whole number, and they want you to use 3.14 for pi. Okay, so I got the formula for volume of a cone from the formula sheet. It's 1/3 big B H. Okay, once again, that big B, I need to spell it out. I need the Achilles version. So I'm real quick going to replace it. And watch, I even like change it up a little bit more because if you're in my class, you know fractions kind of scare me because I make a lot of mistakes with fractions. So you might like the way I rewrite this. Okay, so it's still big B times H, like it's still what we were dealing with before, big B. So that's pi r squared times H. But we have to multiply that by 1/3. Well, guess what, y'all? Dividing the whole thing by 3 is the same as multiplying the whole thing by 1/3. Those are inverses of each other. So for me, rather than having to deal with a fraction, I'm going to figure out the whole total across the top and then divide it by 3 at the end. It kind of takes some more of that pressure off where I could make a little calculation error. All right, let's see what we know. Do we know the radius? Yes. Ooh, nice. They didn't try to trick us this time. Do we know the height? Yes. So we have what we need. Let's start rewriting it. So pi, in fact, I'm going to erase that because they told us to use 3.14. So why not just go ahead and write 3.14? Save a step. So 3.14 times the radius squared, okay? The radius is 4. So times 4 squared times the height, which is 5. I need to get all of that and then divide it by 3. If you hear any weird noises, my sweet, precious angel little dog, Kobe, has decided to come join me. So who knows, he might make some little weird sounds for you. Okay, let's replace this 4 squared, right? Because we know 4 squared is 16. So let's just replace it in our formula. It's just one less thing to worry about. So 4 squared, I'm replacing it with what 4 squared actually is. Kobe is bumping my arm, so apologies for any weird writing that occurs. All right, so at this point, it is calculator time. So we would want to get our calculator out. Let me pull out my graphing calculator and get this total across the top, the numerator. So I'll go ahead and show you that part. So you would want to do 3.14 times 16 times 5. Okay, there's your numerator across the top. Now your last step, all you have to do is take that final step and divide it by 3. If you can do that, you will easily identify the answer here from your answer choices. And remember, round it to the nearest cubic meter, the nearest whole number. All right, let's hop ahead to number 4. Uh-oh, Deadpool special, no picture. We're okay with that though. Deadpool's angry, we're not angry. Okay, so they're telling us that the radius of a sphere, okay, so a sphere, like a baseball, right, is 7 centimeters, a tiny baseball. What is that sphere's volume? Round to the nearest tenth, okay, and use 3.14 for pi. So there's no guessing what to do about pi. They're telling us so far. All right, I went and got the formula for the volume of a sphere. I got it off that formula chart. And you know me, if there's a fraction, I'm going to find a way to deal with it that's a little bit less pressure. So I rewrite this formula too. Just a little repositioning makes my life so much easier when it comes to these fractions. So here's how I rewrite it. 4, because I've got this 4, right, times pi. Okay, Kobe is on my arm. Times the radius cubed. Okay, pay attention. We've switched to the third power here. Get that all figured out, then divide it by 3. It's the same principle as that last one we did. I'm going to take the pressure off myself when it comes to fractions. All right, so this is no big deal. We've got the radius. Like, we can totally do this. They told us the radius is 7. So let's rewrite it and plug in what we know. So the volume is 4 times pi, and they told us to use 3.14. So let's just go ahead and write that, save a little trouble. Times the radius cubed, the radius to the third power. So what does that mean? It means you have to take 7 and multiply it by itself 3 times. 7 times 7 times 7. Okay? So let's get out our calculator. And there's probably a smoother way to do this. There is a way on your calculator to punch in 7 to the third power and have it calculate it. I just go ahead and do it by hand just because. So I'm going to figure out what is 7 to the third power and just replace that in my little formula. So watch this. 7 times 7 times 7, c to the third power, 3 times. That comes out to 343. So I'm literally just going to come replace that in my little formula here with, what was it? 343. So get rid of that. And instead, we're going to do 343. Big numbers. Okay, so I'm going to set you up for success. Let's figure out this numerator all the way across the top. So it is 4 times 3.14 times 343. So there's our numerator. All you have to do is take that final step and divide it by 3. They told us to round it to the nearest tenth, which means we need one number after the decimal. So once you divide that by 3, it should be pretty obvious which one of these is the volume of that sphere. All right, number 5. Boy, we're going quick. In terms of pi, what is the volume of this sphere? So once again, volume of a sphere, and they're telling us to leave our answer in terms of pi. And we can confirm how they want our answer. Look, every answer choice has the pi symbol in it. So when we work out our formula, we don't have to substitute 3.14. We could just leave the pi symbol there. So I'm going to rewrite this to a way that's easier for my brain to handle. So across the top, the numerator is 4 times pi times the radius cubed. Remember, it's cubed. All of that gets divided by 3. Okay. Well, they didn't give us the radius, but they did give us the diameter, right? They gave us the whole way across. No big deal. I just need to divide that in half because each side, this is a radius and this is a radius. Well, half of 60 is 30. So that's the number I need. The radius is 30. Okay, let's fill it out. So volume equals 4 times pi. Remember, they want us to leave it in terms of pi, so don't replace it with 3.14. Just stick that pi symbol in there. Times the radius to the third power. Okay, so the radius we figured out is 30. And we need to figure out what 30 to the third power is. All of that gets divided by 3. Okay, once again, calculator time. And I'm going to just figure this out by hand. I'm going to type in 30 times 30 times 30. I may do things old school, but I tell you what, I do things in a way that lessens the chances that I'm going to make little mistakes. And if I do something slow or I do it manually, I feel better that I'm not going to make a mistake by trying to get cute and take shortcuts. So 30 to the third power is humongous, 27,000. So let's come in here and replace that with the gigantic number 27,000. And you know what? I just noticed an answer on our multiple choice. I see a bait answer, don't you? I bet they're hoping you just stop. And you're like, oh, I got the radius cubed. I found it. It must be C. Oh, these bait answers. Don't take the bait. Okay, let's get that numerator figured out, and then I'll leave you to take it the rest of the way. So we have 4 times, well, the pi symbol. So let's skip over that because really we just need to calculate 4 times 27,000 and then stick the pi symbol on there. So 4 times the absolutely massive 27,000 is 108,000. So I'll go ahead and write this step out for you. Okay, it'd be nice if I had my pencil. Okay, so it was 108,000. 108,000. And then remember, we stick the pi symbol on there. So your final challenge, your final step for this is to divide that by 3. Divide 108,000 by 3. Now, you can't just get rid of the pi symbol. It has to stay on there. But once you take that final step, you will be able to pick out the answer. All right, we are in the home stretch. Problem number 6. Now we are shifting over to surface area. So volume is all about how much you can fit inside something, right? Like inside of a soda can or inside of a box. Surface area is all about how much material did it take to make that container, right? To make that shoebox or to make that label on that soup can. So we have a right rectangular prism, okay? Right rectangular prism. And we can tell by looking at the picture that that's what it is. Find the surface area of this prism. Now, they did not specify whether they wanted lateral or total surface area. When they don't specify, they typically mean total, okay? So I got the formula for total, and we're going to work it out and make sure that's on our answer choices. That's one of the things I love about multiple choice is we'll know if we went the wrong way. I tell my classes all the time, think about Elon Musk, the guy who owns Tesla, he owns SpaceX, and he's got his starships that he's been trying to get ready to fly to Mars. He has crashed 10 of them. He has another one launching this week, and he will probably crash another one. But every time he crashes one, it's a great success because he learns something to do different next time. And eventually one of those rockets is going to land perfectly with no explosions. That's like math, okay? You're going to crash a lot of spaceships on your way to figuring things out. You're going to mess up a lot of problems. You have to try things, okay? Experiment. There's nothing wrong with experimenting, realizing you messed up, and trying again, right? Think about those spaceships. All right, so we have our formula, surface area. Oh, we have a new letter here, capital P. So remember, capital P is the perimeter of one of the bases times the height, plus 2 times, oh, there it is again, capital B, the area of one of the bases. So let's break this up into little pieces. Let's start with this chunk. So big P times H. What is big P? Again, it's the perimeter of one of these bases. So on these prisms, the bases are parallel to each other. They're identical and they're opposite from each other. They're parallel. So like this down here is one of the bases. See, it's sitting on one of the bases. And then the other one, let me get a different color. I wish I had a straight line tool because I know y'all are probably laughing at my bad wiggly lines here. But you see, these are the two bases. I know when you hear base, you think, oh, it's the thing it sits on. Well, there's two of them, right? Think about a soup can. Think about a shoebox. There's a top and a bottom. They're identical, exact same shape. So we need the perimeter of one of those bases. All right, so down here across the bottom, I've got 10 feet. I've got 8 feet. And then as I go back across, well, this one is obviously 10 feet, right? They just didn't label it, but I mean, we can figure that out. Continuing around, and this one would be 8 feet, just like the opposite side. So we need to add that up because perimeter, you total all around the sides. So 10 plus 10 is 20. And then 8 plus 8 is 16. So 20 plus 16, 36 is my big P, my perimeter of a base. Okay, now times the height. The height is the distance between the two bases. So you see these little props right here that are like holding up, keeping the bases apart, that's your height. And it is 1 foot. So for the first part of this formula, it's 36 times 1. Well, what do you know? That's just 36. Okay, so we got the first part done. Check. Now let's move on to the second part. So it's plus 2 times big B. Okay, big B is now the area of one of those bases. Okay, so dig back to elementary school. Remember, you find the area of a rectangle by multiplying length times width. Okay, so the area of one of the bases is 10 times 8, which is 80. So that turns into 2 times 80. Okay, well, 2 times 80 is 160. So we just need to total those up, and I can already tell that is the right answer. So if they don't specify between lateral or total, if they just say find the surface area, assume they want you to find total surface area. I see the answer. I bet you see it too. All right, let's move on to number 7. We're getting so close. All right. Oh, see, they tell us this time, find the lateral surface area of this rectangular prism in centimeters. Okay, so for lateral surface area of a rectangular prism, the formula is much shorter. Big P, which is the perimeter of one of the bases, times the height. All right, so let's come over here and write our pieces. So the perimeter of one of the bases, well, I know there's a base on top and a base on bottom. I can tell because there's two that are identical. They're parallel to each other. And I can find the perimeter of that because this long side is 4 and this short side, the short side is 2. So I have 4 plus 2 plus 4 plus 2. I can do that. 4 plus 2 is 6. 4 plus 2 is 6. The perimeter of that base is 6 plus 6, which is 12. Nice. Okay, remember the height is the distance between the two bases. It's like this piece right here, like propping the whole thing up, right? That's the piece that holds the box up. That is 3. So if you can figure out what 12 times 3 is, and I think you can, you will find the right answer to number 7. Moving on to number 8, a triangular prism. All right, so same type of deal, lateral surface area of a triangular prism. Okay, we have our formula. Where'd we get that? From the formula chart. And it is big P, perimeter of one of the bases, times the height. Now, what is deceiving about triangular prisms is the way they lay them sometimes. The way they have laid this triangle down, this triangular prism down, one would think that this rectangle down here is the base, right? Because it's sitting on it. But remember what I said about bases. There's not one. There are 2 bases, and they are the exact same shape, size, everything. They're twins. So look at these 2 triangles. They are exactly the same. There are 2 of them. Those are the bases. So they're going to try to trick you with these triangular prisms and lay them on different sides and turn them different ways to try to make you think the base is one of the rectangles or one of the squares, but it is not. Your bases are these triangles. So we need the perimeter of just one of them. This graphic is a little busy for me, so I'm just going to come right over here and redraw my own version of one of those triangles. Yes, it's derpy. Yes, you have permission to laugh. Kind of looks like a bird's beak right there. And I'm just going to write in those measurements over here where it's nice and clean so it doesn't confuse me. So that side across the bottom is 12. The long tilted side is 13. The hypotenuse, if you will, ooh, fancy. And this short vertical side is 5. Now, how nice is that for finding a perimeter, right? Because we got to add all the way around the triangle. So perimeter times height. All right, well, let's add around. 12 plus 13 is 25. 25 plus 5 is 30. So big P, perimeter of one of the bases, is 30. Now, see the way they laid this, they want you to think that this is the height, right? Because it's, oh, that's how tall it is. We're not falling for it. The height is the distance between the 2 bases. It's like a bar that keeps those bases separated. See, in this we got 3 that show the height. That height is 4. So if you can figure out 30 times 4, which I think you can, you've got the answer to number 8. All right, number 9. Ooh, word problem. Fun. All right, Michael is painting a cylindrical tank. So we got a cylinder. Very nice. With a radius of 15 feet and a height of 60. That sounds like what we need. That's good. He must determine the surface area of the tank so he knows how much paint to purchase. That makes sense because if he's got to cover the whole thing, he needs the total surface area. So what is the surface area of the tank rounded to the nearest whole number? Okay, we have a lot going on here. We need the total surface area of a cylinder. So I went to the formula sheet. I got the formula. No big deal. We can plug in the pieces we need. But do we use 3.14? Do we leave the pi symbol in there? Do we need to use the pi button on our calculator? Like, what's going on? It doesn't really tell us. So I'm going to look at my answer choices. None of them has the pi symbol in it. So that tells me I need to either use 3.14 for pi or use my graphing calculator and push that pi button. And I'm going to show you the difference. If you're in my class, I've shown you this week. I'm going to show you the difference, how your answers vary, whether you use 3.14, like the shortened version of pi, or if you use your graphing calculator and use the pi button, which uses the entire full 3.14159 go on forever decimal. I'm going to show you the difference. But let's set up our problem first, okay? We'll cross that bridge when we get there. Let's do it one byte at a time. So the first part of total surface area of a cylinder is 2 times pi times the radius times the height. Okay? So we know the radius is 15. We know the height is 60. We're just going to plug in what we know. So 2 times pi, and in just a minute we'll decide how we're going to handle pi. So 2 times pi times the radius, which is 15, times the height, which is 60. How did I get those numbers? Because they're in the problem. All right, let's go ahead and at least do 2 times 15 times 60. Let's get that, and then we're going to deal with pi. Okay, so let me clear this out. Let's at least do the 2 times 15 times 60. 15 times 60. We get 1800. So right now, for the first part of our formula, we have 1800 pi. Okay. Now, let's do the second side, the right side of our formula. Okay. 2, I'm just reading what the formula says, times pi times the radius squared. Nothing here we can't handle. So 2 times pi times the radius squared. The radius was 15, so times 15 squared. Let's go ahead and figure out what 15 squared is, right? Let's go ahead and do 15 times 15 and just replace that in our formula. So 15 times 15 is 225. So let's just get rid of that. Let's erase it and write what it really is. It's really 225. Okay, so this is the right side of our little formula. Let's go ahead and do 2 times 225. Stick the pi symbol on there. We're getting closer to actually dealing with pi. So 2 times 225. Oh, look, I've still got 225 in there. So I could just do times 2, and that gives me 450. All right, so on the right side, I've got 450 pi. Okay. See, I'm just matchy to my formula. My formula had 2 terms that I had to figure out and add together. That's the point I'm at now. I've got 2 terms that I figured out that now I need to add together. So let's add 1800 plus 450. We're going to keep the pi symbol on there, but let's add 1800 plus 450. So 1800 plus 450 is 2250. So my grand total is 2250 times pi. All right, so here's where we have to make a decision, because as you can tell, 2250 is not an answer choice. So we have to decide, are we going to substitute in and use 3.14 for pi? So times 3.14, or are we going to try out using the pi button on our graphing calculator? Let me show you the difference between the 2 answers, depending on which route you go. So let's say you want to just do 3.14 for pi, because that's what you're comfortable with. So 2250 times 3.14 gives you 7,065, okay? So I'm just going to make a note here. If I use 3.14, I get 7,065, okay? I don't see 7,065, but boy, D gets close, doesn't it? So watch the difference when we actually use the full value of pi. So graphing calculator, 2250 times, now right here, the pi symbol, I know it's tiny, it's in blue. That gives you the ability to use the entire value of pi. It's in blue, so you have to hit this blue button to activate it. So second, it's like the shift key on your keyboard, right? And then hit this black button with the little caret on it. That sticks pi into your little equation there. Enter. Now look at the difference. When we use the actual full value of pi, we get 7,068.58. Rounded to the nearest whole number, rounds up to 7,069. So why did I go through all that? If you don't have a graphing calculator and you just need to use a plain old calculator and type 3.14 for pi, you need to be prepared for your answers to be just a smidge off. So if it's multiple choice and you did 3.14 for pi, Find the answer closest to what you got. Your answer is going to be a smidge off. If you use the pi button and use the full value of pi, you're much more likely to get that answer exactly right on the nose. Either way, you're going to get the right answer, though, I do believe. All right, here we go. Last but not least, number 10. Whew, this video is long, but if you're still here with me, you're going to be glad you watched it. Number 10, find the lateral surface area of the cylinder. So remember, lateral is just around the outsides. Lateral surface area is like the paper wrapping on a can of soup, right? The paper wrapper doesn't cover the top and the bottom. So this is like we're finding how big the paper wrapper is on this thing. So the lateral surface area of the cylinder, round your answer to the nearest hundredth. So once again, we're dealing with pi. Our answer choices do not have the pi symbol in them. So we'll have to decide yet again, are we going to use 3.14 and just get as close as we can? Or are we going to use our graphing calculator to use the full value of pi? Either way, you will find the right answer, I promise you. All right, let's write it out. So 2 times pi times the radius times the height. Well, looky here. We have a radius and we have a height. We have everything we need. So 2 times pi. Don't know how I'm going to deal with pi yet, so I'm just going to leave the symbol in there. The radius is 6, so times 6 times the height, which is 10. Okay, I'm at least going to multiply the numbers. So 2 times 6 times 10. Well, 6 times 10 is 60, and then 60 times 2 is 120. So I can get this narrowed all the way down to 120 times pi. So here's where you have to decide, are you going to do 3.14 for pi or use the pi button? So I'll show you the difference. Once again, I'll show you. Let's use 3.14. I'll show you what you get if you just kind of round pi to 3.14. So 120 times 3.14. You see we get 376.8, okay? Now, if I do 120 times the full value of pi, so 120 times, okay, I got to activate pi. It's blue, so I got to hit the blue button, times pi. There's the value. So you see, when you rounded pi off, your answer is just a smidge smaller. But oh my, I think you can pick out the answer, can't you? Ooh, I should get that off the screen. Miss Achille. So you just, on these last couple problems, you just have to decide, and it really depends on your comfort level with your graphing calculator. If you're comfortable with activating that pi button, you will get a very precise answer. If you're not comfortable with it, or maybe you don't have it handy and you instead use 3.14, just be aware your answer is going to be a smidge off, but you'll be able to pick out the right answer, I promise you. All right, my friends, if you are still watching, you are amazing. You are my favorite, and I'm pretty sure you're about to do awesome on this test. Don't forget, it's due by midnight, so by 11:59 p.m. really on Friday, March 12th, 2021. Don't forget, it is on USA Test Prep this time around, a little different. All right, my friends, have a great one. You're going to do awesome. Talk to you next